Hi, we are Group 3 and in this video we will talk about how to apply linear programming to develop the Andrew Carter case study. As we know, operation reserve to make correct decision in the labor field because it allows us to optimize the resources to obtain an economic benefit. Andrew Carter is a company that produces and distributes outdoor lighting fixtures which had a high demand, but due to the reduction in the real estate market, the demand decreased, so they are considered closing one of the three manufacturing plants that distribute the products to five warehouses. The purpose of this project is to give a recommendation of which manufacturing plant should be closed. To develop this case, we will use the GAMS software and apply the transportation model of the linear programming. As a simple analysis of the route can determine which plant should be closed to minimize production costs. To beginning, to to begin, it's necessary to know that the company is considering closing one of the three plants, as they now operate with an excess capacity of approximately 3,400 units per week. Among the data of the case, the weekly demand forecast for next year, as you can see in this table, of each warehouse have been assigned units. You can also see in this table the capacity of the manufacturing plant in units per week. Each plant can produce a specific amount in regular time and overtime. In addition, the case provides the following tables. In this table, in addition, the case provides the following tables. In this table of variable cost for unit and fixed cost of production, which are assigned to each plant if it operates or not. And in this table you can see the cost of distribution of the manufacturing plant for to each warehouse. Now, as we know, the cost suggests finding the optimal solution that minimizes costs if one of the three manufacturing plants is closed. We make a table with the possible combination, and we obtained that in option 1 produce operate plants 1 and 2, option 2 operate plant 1 and 3, and the option 3 the plants 2 and 3. Now we can develop each option in the software and to know which manufacturing plant should be closed.
I'm Lenin Rodriguez. I want to explain the option 1. The option 1 is when the plants 1 and 2 are operating and the plant 3 not operating. In this table we can see the left side the plants 1 and plant 2. Here are the warehouses are 5. These numbers are the production cost plus distribution cost from plant 1 and 2 to each warehouse 1, 2 and 3, 4 and 5. This number are the limited capacity of plant 1 and plant 2. In this number is a limit demand of each warehouse. This number is the difference between capacity and demand. Decision variables. These are xij. It is the number of units produced and distributed from plant I to warehouse J, where I it is 1, 2, 3, and 4, and J is from 1 to 5. Also, Pi it's, it is quantity offered from plant I in regular time. Pxi it is quantity offered from plant I on overtime. Aj is the quantity demand from the warehouse J. Objective function. All objective is minimize cost. Cost is represented by C. It is result from product between cost with the number units of produced and distributed for each plant, plant 1 and plant 2. Also, the constraint. Constraints there are offer and demand. The constraint offer are 4 and the constraint demand are 5 and the constraint non-negativity. Now we can solve the problem of linear programming using GAN. First, define the variables. The variables are manufacturing plants and warehouses. Warehouses are A1, A2, A3, A4, and A5. It is J. And manufacturing plants are P1, P1, P2, and P2. It is I. Second, in parameters, we define the limits of plants and limits of warehouse. In plants, P1 is 27,000, P1 7,000, P2 20,000, and P2 5,000. In limits of each warehouse, A1 9,000, A2 13,000, and others. 2. Table. Table is defined by columns or warehouses. Warehouses are 5 and the rows are manufacturing plants. They are 4. Positive variables are all the x, the I and j. In variables, it is the objective function. It is represented by z. Our objective is minimize the cost. In equations are 3. FO, EQ1 and EQ2. FO is the objective function. EQ1 is the limited plants and EQ2 is the limited warehouses. Model. Model is the name of our model. In this case is plant 1, 2. Insert the previous model using linear programming, minimize Z or cost, and displays the objective function and the variable. Finally, we can run the program. We can see the minimum cost is 188,900 930. It is the minimum cost. In GANs I got, the minimum cost is $188,930. Also, there are at the fixed cost of plants 1 and 2. It is 14,000 and 12,000, and the cost by not operating of plant 3. It is 7,500. Therefore, total cost is $222,430.
Well, continuing with the case of Andrew Carter, now we flow plant 1 and plant 3. In this picture, see table costs and plant 1 and 3, capacity supply in the column, and demand in the foil. The decision variables, number of products and distributed from plant 1 and 3, and the variables quantify offer when the plant 1 in regular time, quantify offer when the plant A in extra time, quantify demand by storehouse, the function objective, and the restrictions subject to supply and demand. Well, the GAN solution. The GAN solution is the table is the capacity, supply, and demand. The command J parameters. The first specific set, A plant of fabrication, and the J storehouse of distribution. The table in this case is the cost. Well, the positive variables, the variables in this case minimizing the function objective and the equation function objective and two equations, equation 1 and equation 2. The function objective is this command, and the equation 2 the sum capacity plant, and the equation 2 demand storehouse. The model in this case is the plant 1 and 3, and the finish solve plant 1 using minimizing function objective, in this case Ceph, and display Ceph and 8. The function objective in this function this, and the result is what should obtain as minimization cost to the added the fixed cost operation of plant 1 and 3 respectively, 14,000 and 50,000 respectively, and the cost not operating plant 2 is 500, resulting the total cost is 270,430. Distributor of follow using GAMS of plant 1 and A2, the plant 1 and A4, plant 3 and A1, plant 3 and A3, the plant 3 and A4 of plant 3 to A5 respectively. Obtain the total cost is this number using program GAMS of the conclusion.
Option 3 is what would happen if only plants 2 and 3 operate. it has this table with all costs of plant 2 and 3 and the supply and the demand. Decision variables are defined as x sub ij is the number of units produced and distributed for plants I to win j, where I can be 1, 2, 3, 4 because there are 4 ways in which plants operate, and j can be 1, 2, 3, 4, 5 because there are 5 wins. Also, Pi is quantified offered by the plant I in regular time. Pxi is quantity offered by the plant I in overtime, and Wj is the amount demanded by the win j. Then define the objective function. The objective function is the sum of all costs with their respective variables. The constraints. There are 4 constraints or supply and 5 constraints of demand. Now in GAMS, put all the information. Set is the plants and the winds. Parameters is the supplies and demand. Table is the same table. Here. Positive variables is x. Variables is the cost to minimize. Equations. In this case, there are 3 equations. And it's all. Now run the GAMS. The software gives us the minimum cost is this, and the solution of variables. So a minimum cost of $188,316 was sustained, but this amount is set to 12,000 and 50,000, which are the fixed operating costs of plant 2 and 3 respectively, and also 6,000 for non-operating plant 1. The total cost is $221,360.
When evaluating all the possible operational settings and plans that will fulfill the weak demand, we got the minimal difference of total cost about the combination done. Moreover, at the same time, it shows the extra time is very necessary to luminary productions. That's why the best choice is that both plant 1 and plant 3 were closing plant 2, because with this plan the total cost goes down to $270,430. Let's see the next distribution. Where the total units produced will be 56,000. This makes more benefits to the company in other costs like fuel, workforce, or personal hire as the transport units. Also, it's important to remember before make a choice, it has to make a hard study of all alternatives. This allows us to conclude that the operational investigation, especially the transport pattern, is usefulness to all companies, particularly the ones with different distribution centers, because every day, weekly, or monthly, they have significant costs for the productions. Without a doubt, it's recommended to use a linear programming because it can be implemented in various activities of a company, as it serves as a tool for optimizing profits, resource costs, among others, thus improving the
performance of the company. As in this case, the study of the transportation model was applied, it should be recalled that where this model is applied in a problem as the Andrew Carter case, it is essential to be able to recognize which is the environment of activity and that is to be transported from source to destination in such a way that one could realize correct definition of which will be the cause or variable set.